All right, so today we are going to do February, March 18, 1, 2. What is equivalent to a coulomb? So first of all, let's look at the formula. So charge equals to current into time. So the first one is wrong. Don't know this, don't know this. This could be something because energy is voltage times charge. So charge will be joules over volts. So this could be correct. Then which shows a quantity that are incorrect units? Efficiency, that's right. Moment of a force, Newton per meter. That's wrong. Two forces. One east, one north. What is single direction that will balance these forces? So the resultant is going to be here. So the force that should balance should be here. So this was south, this was west. So we should look at towards southwest. Okay, then okay. So we have a sheet of paper. 210, 300. Density. Thickness of 500 is this. Right. So what is the mass of single sheet? So thickness of single sheet would be 50 divided by 500. 1 upon 10, right? Millimeter. So the volume is going to be 0.1 into 10 raised to power minus 3 because we want to convert it into meters, okay? 210 and 300. So pull up the calculator. 0.1 times 10 raised to power minus 3 times 210 times 10 raised to power minus 3 times 300 times 10 raised to power minus 3 comes out to be 0.0000063. Okay, so density is mass over volume. So we got to multiply this by density. So it is 0.00504 kg. That brings it up like 5.04 grams. That should be the answer. Okay, so to find the greatest contribution, percentage in inserting calculated potential difference. Right. So potential difference is given by IR. Okay. There is no resistance, so we can replace resistance with rho L over A, like that. There's no area, so we can replace it by D square, 5 by 4, D square. So now our formula basically looks like this. Rho L over 5 by 4 D square. So let's try and find out the percentages out of it, and then we'll know which one has the largest contribution. So 0.5 divided by 5.0 times 100, that is about 10%. Then 0.1, this is the diameter, okay? 0.1 divided by 0.8 times 100, 12.5%, but there is a square on it, so we are going to multiply it. So it's going to be 25%. This is 5 divided by 150 times 100. So that's 3.3%. and that should be pretty low. 0.2 divided by 1.6 times 100, so 12.5%. So definitely the diameter has the greatest effect on this. Now cathode ray oscilloscope, time base, Y plate. Which statement about the alternating current is correct? So this is the middle of the wave or the signal. The amplitude is this, that is wrong. This is just the display. The frequency is 5. Okay, let's try finding these 4 boxes. So time period is time-based setting times 4. So that's 2 seconds, 2 milliseconds actually. So frequency 1/2 times 10⁻³ 1000 divided by 2. Frequency is 500 hertz actually. 0.5 kilohertz is the same as this, right? So it has to be B, no doubt. Very tricky. That's the same thing. Then here, the stone of mass M, right? When the stone is falling terminal velocity, which information? Magnitude of acceleration should be 0. Magnitude of force of gravity, mg and mg. Magnitude of weight resistance should be mg. Has to be B, no other way. Balancing for forces. Then how can the total displacement of the object can be determined? Area 1 minus area 2. Area 2 minus area 1. Well, that's fine. You could, no, area 1 minus area 2. That's correct. Okay. When the girl throws vertically upwards, it takes this much seconds to return to her hand. Okay. What is the initial speed? So it goes up, it goes down. Displacement. So what we can do, we want to find initial speed. So displacement is equal to, let's, for you guys, SUV 80. Displacement is 2s. Initial velocity is what we need to find. Final velocity is not known. Acceleration is just take minus 9.81. And time is 3.20. Because it's going up, right? So I took it like this. So well, we don't have the displacement. We can't use it, right? Just 2s.
Sir, why is it 2s?
It goes up and goes down. Oh, it has to be 0, right? Yeah, it has to be 0.
Okay, sir.
Final velocity is not known. If we use it, let's try. Maybe this works out. This is 0. Why it is 0? Because if you take it positive, you have to take it negative. This is what we need to find. 3.20 plus half minus 9.81. 3.20 square. So I have another method too. Let's try that too. So 0.5 times 9.81 times 3.2 square. So it's 50.2272 equals to U 3.20. So U will be divided by 3.20, 15.7. So this has to be the answer. But let's try with another method. If we take just the half, like go up, this is S. U is not known, V is 0. And time should be half of it now. 3.20 will be 1.60. S not known, 0 minus 9.81 and 1.60. Now we can just use U plus 80. 0 U minus 9.81 and 1.60. Let's try. This is much simpler. 9.81 times 1.60, and it comes out to be the same. So both methods are perfectly okay. Okay. So right now we have stone pellets falling with U, going up with B. So, right. If I take this as positive, I have to take this as negative. The time is 60 seconds because it's 1 minute, right? And there are 100 pellets. So the total mass is 100 times 0.60. So that has to be 60 grams. You can convert it to kg. So it will be 0.6 kg as 0.06 kg. Okay. Now what you do? Change in momentum. 0.06. Final velocity was -4. And minus initial velocity was 0.6. 0.06 times 5. So 0.06 times 4 plus 0.06 times 5. So the change in momentum would be minus 0.54 Newton seconds. Now force, change in momentum of time, minus just for the direction we took, so it doesn't really matter. So we divide by 60, 0.09, it has to be C then. Okay. Going next. So on this side, you have 60 newtons. On this side, oh, and in this side, they cancel out. So resultant force has to be non-zero. And the torque, well, the torque would be non-zero as well, because this is like not producing a torque, but these are like they're coupled forces. So it has to be A then. This is not clear anymore. In which example it is not possible for underlying body to be in equilibrium? Aeroplane climbs at a steady rate. Well, it is climbing at a steady rate. So that means climbing is displacement. Steady rate means constant velocity. So that's not the answer because it's in equilibrium. And airplane tows a glider constant altitude. Okay, so that's balanced as well. Speedboat changes directions, constant speed. So changing direction is due to acceleration. Has to be this answer. Two boats tow a ship into harbor. Not enough information is given, so that's ambiguous. So we choose C. A car of mass 1100 kg is traveling at constant speed up a slope inclined at 10. The combined friction forces act on car directed down the slope are combined friction forces directed down the slope are equal to this. Where W is the weight of the car. What is the power output? Useful power output. Right. Constant velocity means that the forces that are here are also balanced. So one, this is the weight. So weight's component here, like this component would be W sine theta, and the friction forces are W over 5. So total forces backward are W over 5 plus W sine theta. that should be the equal to forward forces. So we want to find this first. So I don't know what sine 10 is. Sine 10 is this. Okay, that's fine. So we have to do 1100 times 9.81 over 5 plus 1100 times 9.81 times sine 10. So that would give us the answer basically, like the force. Plus okay. So the force comes out to be 4032 newtons. Now power is force times velocity. 4032 times 15. This is 60,000. That should be this answer.
सर ये वाला सवाल दोबारा समझा दें.
Okay. So what I did was, I know the weight of the car has to be down. Weight has two components, one always down the slope and one perpendicular to the slope. So I want to know what is this component. So this should be W sine theta, as this is 10 degrees, right? Also, it says the friction forces on the car are equal to W over 5, right?
Yes.
Now, you see it is going at constant velocity. This means the sum of the backward forces must be equal to the forward force. Otherwise, it would not go at constant velocity. What do you think?
Yes.
So F is equal to this plus this. So I found this, like found the weight, put in the value.
Okay, sir. Got it.
Then I power equals to that.
Thank
Okay.
you.
An old-fashioned 60-watt lamp converts 95% into heat. A 4-watt lamp has the same power output as old-fashioned lamp. What is the efficiency of modern lamp? Whoa. Okay, let's try this. So 95% of 60 is wasted, right? So only 5% is useful. So 0.05 times 60, that's 3 watt. Now that's the output, same as this one. So 3 over 4, output over input times 100%. So that's 75% efficient. Great. Okay, this was pretty simple. Bead is released from rest. Okay. The track loops around to form a circle. Diameter is this. Bead has a speed of this. Air resistance friction, the wire is negligible. What is the height h from the bead is released? Now, first of all, I would want to know what is the total energy this bead has here. So it has potential energy and it has some kinetic energy as well. So if I know this, then I'll know what will be the total gravitational energy that was given to it. Interesting. So potential energy would be M. Do they have mass? They haven't given us mass, right? Fine. mgh plus half mv square is the energy there, and mgh here. So we write now mgh equals to mg, and we have to 0.4 meters plus half times 1.4 whole square. So mass cancel. So 9.81 times h equals to 9.81 times 0.4 plus half times 1.4 whole square. Let's try it now. Right. Divided by. So this is 0.50 meters. Pretty badass this question was. Now, a small diesel engine uses this much of fuel per hour. Useful power output. It may be assumed that 34 transfer to engine weight uses 1 centimeter. Okay. What is the rate of transfer of energy wasted? Okay. First of all, we have the output power. We want to find the input. So 1 centimeter cube gives like 34 kilojoules. So 1.5 times 10 raised to 4 would give how much? You cross multiply. So 1.5 times 10 raised to power 4 times 34 would give us 51 510,000 kilojoules. What you do then? You got to divide it by an hour to find power. In an hour, there's 60 minutes and 60 seconds. So that is about 142 kilowatt. Now, how much energy is wasted? So the formula is input equals to output plus wasted. So 142, 30, 40, sorry, plus waste. So that should be 102 then. Pretty simple. Not complicated at all. Now, two boxes X and Y have the same mass, but box X is lifted vertically through height h by a force of F. Box Y pulled along the surface, same magnitude. So which statement is correct? Both boxes gain the same amount of gravitational potential energy and same amount of work done by the two forces. Well, I disagree, because not only it is moving in this direction, so it's doing work against friction. Also, it is doing work in the height, so you need more work to do here. That's wrong. Both boxes, same amount of gravitational potential energy, but more work is done by force acting on Y by force acting on X. That's correct, because I told you why. There has to be friction to pull it up. So you have to overcome that too. Well, there can't be less, there can't be more. So both are wrong because they gain the same height. At which point the graph does the metal wire stop obeying Hooke's law? At which point it, after A, it would not. Okay. A model of crane and its load and the cable supporting the load. The material used for each part of the model is the same as that of full-size crane. Cable and load. The model is 1/10 full size in linear dimensions. What is the ratio of stress? Oh. So cable and load, the model is 1/10 full size of the linear dimensions only. Well, that's interesting. So this means that 1/10 area is generally d squared, right? So if diameter is 1/10, so the area will be 100, right? Area will be 100 times smaller for the wire. Length will be like 1/10, right, of the new length. Area will be 100 of the original length. Okay. Now, it doesn't say that, it doesn't really say whether the force is same or not. Anyway, so stress is force over area. So the force, let's say, was F on it, and area was A, and this is for full size, and for model, it would be force will be F. Well, I'm just guessing that force should be F, but I don't know. Let me think about it. Why should we, force cannot be the same, right, on model and that? So let me think about it. We can, if say force was this, and force comes from mg, and m comes from density times volume, right? So density is the same, this is same, material G is the same, volume is different. So volume is a three-dimensional thing, length, breadth, width, right? So we can say that if each dimension was reduced by 1/10, then the volume, the new volume will be 1/10 cube of the old volume, because the three dimensions, right? So three dimensions turned. So there has to be 1000. Now volume, like if I see the force, that depends on this. Now force and volume are directly proportional, which means if volume was reduced by 1000, then the force should also be reduced by 1000. Well, that makes sense, because then model will have 1000 smaller force and area would be 100 times smaller. Now we can check it out. So 100 divided by 1000. Now what, wait. Okay. So the actual model will be force over area. The actual crane and the model will be 100 divided by 1000 force over area. So that makes it 0.1 force over area. Okay, now we take the ratio. So 1 upon 0.1 is 10. Has to be 10. Very difficult question. Has to be C then. Suman, is it clear or should I repeat it?
No, sir, it's clear.
Okay. Now that's pretty good. Now, which diagram shows the variation with time t, displacement s of the particle rho? So first, when the wave reaches here, so this point will go up, then stay like this, then go down and stay like this. So we have to see a mirror image some sort. So first it goes up, then it should stay like this. So that makes sense. D is the answer there. Others are not. But this goes down, that's wrong. Goes down, that's wrong. It goes up and then down, that's wrong. It should stay here and then go down. That's D. Which graph is labeled correctly? All right. Isn't first one the one I think is correct? Everything seems correct. Why is this wrong? Because time period cannot be found on distance. Amplitude is wrong. And here amplitude is also wrong. Okay, this is a rote learning. So microwaves are 10 raised to minus 2. Infrared, correct. Ultraviolet, correct. And X-rays are correct. So that has to be this one, just rote learning. If you learn this, that's fine. A vehicle carries a micro transmitter that emits microwave constant frequency. A stationary observer has a microwave receiver. Vehicle moves towards at constant speed. The observer detects microwave frequency. The vehicle then accelerates, still moving towards the observer at higher speed. Okay. So I think for this one, he's going to observe a frequency. First, vehicle moves directly at constant speed. So the frequency should be smaller first. No, frequency should be higher because it's moving towards the observer. Yes. So it will be this or this. These two are wrong. And then for some time, because it's constant speed, it should remain steady. And then if it's accelerating, then the frequency should reduce even more, fall to a lower frequency. It has to be C. Okay, then the time-based setting. What is the statement? Okay, well, you have to find it. If this is 1.0, this will be 1.02. So the displayed wavelength is 2 centimeter. You can multiply it with 2 microseconds per centimeter. This will give you the time period. So this will be 0.40 microseconds. The frequency will be 1 upon 0.40 times 10 raised to minus 6. 10 raised to power 6 divided by 0.4 is 2500. 2500 2.5 megahertz. Okay, so naturally this and this is wrong, and AB. The frequency wave is this, and it lies in microwave region. Interesting. Microwave region frequency is 10 raised to power 6, or the other one is radio wave. Radio wave is this. So we need to actually check using V is equal to F lambda actually. So microwave is generally wavelength is 10 raised to minus 2 in microwave, right? So 3.0 times 10 raised to 8 and divided by 10 raised to power minus 2. So it has to be somewhat like 3 into 10 raised to power 10 hertz. So that means that it has to be in the radio wave because it is much shorter. Now, in double slit interference experiment, light frequency is this, uncertain pair of flashlights. Okay, so this is the, what is the separation of bright fringes when the frequency? What? So you have the frequency. Bright fringes that are 3 millimeter apart are observed on screen some distance away. What is the separation of bright fringes when the frequency of light is changed to this? Okay. Ax equals to lambda d. Because they're talking about frequency a lot, we can use lambda equals to speed over frequency. We can replace it here. Times t. Now, if you check, what are the constants here? A is a constant, D is a constant, and C is a constant. So X is inversely proportional to F, right? Now, I told you how to make a ratio of it. Whenever the inverse proportion is, you can write it as X1, F1 equals to some constant K, and which is also equal to this. Now add in the values. So that's 3 when the frequency was this. That's unknown when the frequency changes to this. Now,
सर इनवर्स प्रोपोर्शन है तो 1/k नहीं होगा?
1/k नहीं, ये है ना inverse proportion. When you multiply F here.
Oh,
right?
okay, sir, got it.
So it will be like that. 1 upon the direct में. This was direct. Then you would write X1 over F1 equals to K, like that.
Okay, sir, got it.
Now, now it's pretty simple. All you need to do is calculate. 14 cancels out. So 3 into 6 divided by 5. So that's 3.6. Ta-da! Easy. Now, this is again as this, okay. So this is A. Bright and dark fringes observed, a distance of this is D. The distance between adjacent bright fringes of this is X. What is the path difference between light waves from two slits that meet on the second order dark fringe? Okay. So first of all, we would want to find the lambda. Ax equals to lambda d. So A is 0.1 times 10 raised to minus 3. X is 8 into 10 raised to minus 3. Lambda and D is 2. Let's try to find this. So lambda comes out to be 0.000004, I think. So 4 into 10 raised to power minus 7. Okay. Now, path difference is basically equal to n lambda. In dark, when there is constructed destructive interference, n has to be 0.5, 1.5, 2.5, and so on. So say, what is the path difference between light waves of two seeds at second order? So this is the first order, second 1.5. So we will write 1.5 times 4 into 10 raised to minus 7, like that. So this is 0.0000006. So 6 into 10 raised to minus 7. Is there an answer? Yes, there is. Kya baat hai? It's not very hard if you know what path difference is, really. Okay. Okay. Assuming the end correction for this negligible, what is the equation correct? In this one, the frequency is given by V times N over 2L. You should remember the formulas. In this one, it is V times N over 4L. In this one, N is 1, 2, 3, and so on. In this, it is 1, 3, 5, and so on. Right. Okay. So it says lowest frequency. Lowest frequency means N is 1. So Fx will be V times 1 over 2L. And Fy will be V times 1 over 4. But the length is 2L, like this, right? You can see. So this will be V over 2L. This will be V over 8L. Now we can, we want to substitute V and L because in the answer it's not there. So we can write 2Fx equals to V over L and 8Fy equals to V upon L. So you can now put them together. All of them are, Fx is the subject, so it has to be 4Fy D. Okay, pretty simple, not that hard. Now, next.
So could you explain that again, please?
Yes. So you know the formulas for open, closed, one
Yes,
end
sir, वो
open.
याद है.
Okay. So this formula is Fx equals to V times N over 2L, right? In both open
Yes,
ends,
sir.
N is always 1, 2, 3, and so on, right? In this
Yes.
one, Fi will be V times N over 4L. And in this one, N is 1, 3, 5. because it says this is the lowest frequency. Lowest frequency means both have the starting n. That's 1, right? So I can write it as v times 1 over 2l. I can also write it as v times 1 over 4l. What do you say? Oh,
Okay,
and
sir.
here you have to write 2 because this is 2l, right? Not just 2, right? Now,
Yes, sir. Go ahead.
this becomes v upon 2l. This becomes v over 8l. Now, let me write it here. Now, in the answers, you see there is no v and l, so we can make that the subject. 2fx, v upon l, 8fy, v upon l. Both have the same terms, so we can substitute. So 2fx equals to 8fy. What do you say? Now make
Okay, sir.
the subject, so it is going to be fy. Okay.
Okay, sir. Got it. Thank you.
Now, 29. Which statement gives a condition that enables diffraction to occur? Source waves towards the stationary observer. Nope. Wave is partially blocked by an obstacle. Obstacle. That's correct. This is the condition. Don't need to do this. Don't need to do this. Okay. Which statement is correct? When the switch is SS closed, the EMF of battery falls because work done against internal resistance of the battery. EMF never falls. Potential difference. Terminal potential falls. When switch S is closed, the EMF of battery falls because work done against the resistance. EMF doesn't fall. When switch S is closed, the potential difference across the battery falls. Because this is correct. Because the terminal potential would fall, not the EMF. Because work done against the resistance R, that's all. It's not about this, it's about the internal resistance only. Now, the resistor has a resistance R. When the potential difference across the resistor is V, the current R is I. The power dissipated in the resistor is P. Work done in charge flows. What is not the very valid relationship? These apply. Okay. Well, this one is correct. Its power is equal to VI. Voltage is equal to work done on charge. This is correct. Okay. Power is equal to I squared R. That's also correct. What is this? Power is equal to V upon R. It should be V squared over R. This is wrong formula. What is the length of the wire? 4.90. Is there's a diameter? Okay. 5 by 4. 0.280 times 10 raised to power minus 3 whole square. Whoa, complicated. कर लेंगे tension नहीं. So you multiply the whole term here. Square. Oh, I did not write. See, mistake. Don't forget it. And then divide by 4.90. 10 raised to power minus 7. Oh my God. Is that even? Does it make sense to you? It doesn't really. Oh, what did I do? I made a mistake actually here. On this side, I made a mistake. On this expression. I tell you why. See, this happens when you're lazy and you don't want to write. Basically, I did not have to divide it, I had to multiply it. Ah, see, time wasted. Never mind. 5 by 4, 0.280. Okay. $1.2. Correct. Very good. Okay, so lesson number 1, don't be lazy like me. Okay, the charge carriers, each of charge Q moves along a wire. The number density, okay, which is also required for this wire to determine the average drift velocity. I equals to N AVE or Q, you say. So they have given N and Q. We don't have the area, right? Current per cross-section area, that's correct. You don't have this, we don't have this. Pretty simple. Now it says one is variable resistor, the potential difference across X is Vx. As the resistance of X is increased, what happens to Vx? Vx will rise, Vy will fall because they're like balancing each other, right? So what gives us this rises, falls? Okay, if I see this portion and this portion is in parallel. So basically, if I redraw this, it will be like this. They have just tried to confuse you, and the voltmeter is right here. So we want to find the voltage here. V out. We want to do this expression. This is 2, this is 4, this is 12. So we're not even looking at this. You only need to look at that. So the formula for potential divider, if you don't know, is V out equals to R1 plus R2 times EMF. So in this one, we want to find here. So the resistance across is 4. So 4 divided by 4 plus 2 times E. So it is going to be 6 or 8. So V out for E is going to be 6 or 8. 6 or 8, my buddies, is 0.75. 0.75 is
12 को इसलिए नहीं लेना क्योंकि वो पैरेलल में है.
yes.
ओके सर.
इससे हमें कोई कंसर्न नहीं. 0.75 is 3 by 4. Is there even an answer like that? Why?
सर 2 by 3 आंसर है.
2 by 3. Sorry. 2, 3. 3 by 4 नहीं आ रहा. Why? What is this even? 4 by 6 है. मैं 6 by 8 क्यों लिखा हूँ?
सर 4 by 6 है.
That's right. मैं वही तो कहूँ, आंसर ही नहीं आ रहा. That's not fair. Okay. Pretty good. What is the total resistance between P and Q? This is 28 series. This is also series 6 plus 8 is 14. 1 upon 28, 1 upon 14 plus 1 upon 7 equals to 1 upon R. So 1 by 4, R is 4. What is this? This is O-level question. I mean, why? Why have they been given this? A nucleus of neptunium.
Sir, can you scroll up please?
Yes, please.
Okay, sir. ठीक है.
A nucleus of Neptunium-236 contains 93 protons and 143 neutrons. Nucleus decays with alpha emission, beta particles. Okay. So when it decays with emission alpha particle, a nucleus formed, then beta particles released. Right, my friends. So when alpha particles release, 2 neutrons are subtracted, 2 protons are subtracted. The new one will be 141 and 91. So let's try that. Where is it? First of all, we need to see where it starts from. 236 minus 93, 143. So 143, 143, 143, 143, all of them start like this. So now we have to subtract 2 neutrons, 141. That's not correct, right? That goes up, that's not correct. 141, this and this could be correct. Now let's see. And then with the new beta particle keeps the neutrons. No. Beta particles reduces the neutrons by 1, increases the proton by 1. So these has to be the answer, I think. There's no other way. It goes like this. Anyway, which neutron decays into proton? Beta and beta negative antineutrino. Which row graphs? Okay. Neutron is UDDU. DDU. Proton is up, up, down, up, up, down. And type of force in this is strong nuclear force. So wait a second. It says which
Sir, weak नहीं आता.
decays, yes. In weak nuclear interaction, this happens. It's correct. Okay, you guys have any questions now?
Sir, could you explain question number 10 again, please?